You're traveling into imaginary space, the same 3 dimensions you've known since you were born. A wondrous illusion created by the placement and combination of only 3 lines. We'll call them X, Y, and Z. Perspective lines take us into imaginary space. Before we learn to navigate and measure in there, we need to know the 3 guiding lines. They're called axes, plural for axis. It just means a line, usually one you can't actually see. An imaginary line can help us foreshorten. The long axis shortens when it points toward us. Pretty much every object has a long axis, unless it doesn't. So we need a system that works for all forms, including environments, which can get complicated. But here's one way to solve it. Rather than start with the whole scene, we can start with placement lines. Big jump from placement lines to city street. But placement lines give a base from which to jump. We can imagine 3 sets of lines, and those 3 line systems position the whole scene. 3 line directions let us find other lines. Now, let's see where we are. We learned about angles and protractors. That was the flat surface out of perspective. You put a good deal of work into getting an eye for those angles, but that was only a start. It wasn't yet space. Then orthos. Orthos say this flat surface means something more, a thing that is not flat. But now we move into the really hard views that slant into space. Prepare yourself here. 3/4 views, oblique views, tipped, tilted, slant, at an angle. That changes everything. How could we ever predict it? I got an idea. Tilt it back behind a window. Look at the window and measure the angles on the window with a protractor. That is how perspective works, and we could take the time to label those angles, but would we? If we do, it names angles, but it wouldn't help much with learning to draw besides noticing angles and labeling them. Not enough. You could get old doing that and not learn how to draw in perspective. We are about to learn something simpler and more useful. The simplest and most useful angle of all, the right angle. 2 lines. Oh, I'm sorry. 3 lines. One I forgot. Right here where the 2 lines meet. Can you guess it? If you're thinking a 45-degree angle comes out of there, you're learning the protractor. Good. But that's not a right angle, and that's not where we're going. There's another right angle facing toward us. We're looking right at it. It's pointing at us. Let me show you. It's a right angle to vertical if we look at it from one direction, and it's a right angle to horizontal if we look at it from another. This is how we coordinate space. This 3-dimensional compass of X, Y, Z arranges the 3 poles of space, each at right angles to both of the others. Let's think about that. A compass rose shows north and south, up and down on the map. It shows east and west, right and left on the map. But it doesn't show a 3rd dimension unless we give it an axis that's upward, not northward. With 3 axes in an oblique view, we have the most simplified arrangement possible to navigate space. Naming the axes. Why do we use letters? We could say up and down, left and right, close and far, but spin this, and what was up is now left. What was left is now far, or close. So we can't always name a line by its position or where it points because that may change. X, Y, Z lets us place objects so that even in different positions their names stay the same and it still makes sense if they spin or tumble. How about environments? They don't spin into different positions. But we do. In environments, we use letters for axes in case our viewpoint changes. But you can call the axes anything as long as they don't get confused with their directions on the surface. This is not about the surface. This is about the world in there. If we move around in that world, every angle on the surface changes. How can we keep track? Remember that a setting, like a form, has its own set of axes. Sometimes axes have vanishing points, sometimes not. Sometimes the vanishing points are close, sometimes distant. The thing that stays constant is the name of each set of lines from the orthos. By the way, some systems swap out the Y and the Z. No biggie, different names, same thing. Let's review the names that we'll use in this course. X is width of the object, not its direction on the paper. Y is height of the object, as we named it in the ortho. X and Y represent width and height of an object. X and Y could still be flat dimensions if they are flat designs, but Z requires us to acknowledge depth and usually introduces a vanishing point. But our concern here is only that 3 sets of parallel lines cover all 3 dimensions. Those are the axes. They will apply to very complex objects as you advance. Let's prepare with a literal assignment. Your assignment is simple. You literally assign one of 3 letters, X, Y, or Z, or any system you're used to each set of lines in these images. If you go to proko.com/perspective, you'll find these 3D models which you can use to do this assignment. We've made a number of them available for free. You can also find them on the Zolly app with even more options to choose from. That's at proko.com/Zolly for the motherlode. Then sketch from each image. Sketch the object, sketch the scene. Don't get fussy. Doing several a little loosely is better than doing only one very precisely. Find the 3-line systems, label them to recognize which line system this line belongs to. Naming these lines should be easy. Everything here is lined up. This is the easiest level. You may get through it fast. Here's the next level. Here things are not lined up. That means that this could be X or Z. You can decide which is width, which is depth. The important thing is that once you decide, stay consistent as you work through the object to rehearse your awareness. Remember, the letters you choose don't change their names when an object changes position. Y does not turn into X when it lays horizontal, when it lies horizontal, lose horizontal, whatever it does. We label per object so that when objects tumble, we know which direction is which. If this still seems too easy, try the next level. It includes bevels, diagonal lines. That means they move on 2 axes. Scary? Perhaps, that some of these lines move in 2 directions at once, but we can deal with it. We label them not as belonging exclusively to one of these 3 directions. We name 2 axes on which the lines move. X, Z. That's width and depth. Or ZY. That's depth and height. Or XY. That's width and height. If you are cutting these boxes, you move the cutting blade out and back, or up and back, or in and up. 2 axes combined, 2 letters assigned. If you want the hardest of all, try lines that move on all the 3 axes. Say out loud the directions in which each line moves. This lets you know that more than 3 axes exist. So why only 3 letters? If you want more, here's where to find them. Spherical coordinates, axes that could melt your brain. This simple labeling gets your brain ready to handle that heat. The secret is not to learn all of those lines in between. It's to learn primary lines which give you the lines in between. It's something like color. 3 primary colors yield lots of others. 3 primary axes give us enough to deduce the spatial structure of the globe. Notice the primary lines, 3 to begin. This will expand your awareness of spatial dimensions, X, Y, and Z, and the parts in between. If you need help, I'll demo in Premium, explain sections, and show you how to position objects in space using 3-dimensional arrows. You'll learn how every straight line relates to X, Y, and Z. I think there's a song about it. You can study many lines, or you can study 3. Everything spatial is X, Y, Z. Okay, label and sketch. In the next free episode, we'll see how grids can help us in guessing proportions.